In this video, we are asked to find letter E, which is there, and letter F, which is there. So we're firstly going to start by finding E, right? So ladies and gents, I'm sure we can all see that O is our center. So O is the center. All right. And then we are going to use what we have and try to see. So guys, here I'm going to answer this question in two ways. Ne? The first one, I'll call it 1. So guys, I'm given this angle here. And this angle is 35 and it's on the circumference, right? It's on K. And K is on the circumference. So angle K, which is 35, is on the circumference. And there's a theorem about angle on center is 2 times angle on the circumference. So immediately I have angle on the circumference. I'm trying to see if I don't have a corresponding angle at the center, right? So I can see that, okay, on this side, this line ends up on J. On this side, this line ends up on H, which means chord JH subtends K. Because you can go this way, and then from there you go that way. So JH subtends K. Right. And then I'm going to look for other angles that are subtended by this. You can see that you have JO here. So O. And then you have OH this side. So there. So this angle, it's also subtended by J and H. And the good thing is this one is at the center. So we can now see that, okay, JOH is equals to 2 times angle at the circumference. Then your reason will be angle at center. Angle at center is equals to 2, oh sorry, let's do this, 2 times angle at circumference. Angle at center is equals to 2 times angle at the circumference. So you can see that JOH is 70 degrees. Then whatever value you get, always come and write it down here. So that is 70. And then now we can easily see that, okay, OJ is the same as OH, right? Your reason is radii. And then you can say this. Therefore, you can see that, okay, in this triangle, which is an isosceles triangle, angle JHO is also equals to E. Your reason will be a triangle OJH is isosceles. Right. So you can see that this is E as well then. Therefore, you can see that now using angles in a triangle, angle E plus angle E plus 70 is equals to 180 degrees. Then your reason will be sum of angles in triangle. They always add up to 180. And then 2 angle E, when you add this together, will be the same as 180 minus 70 degrees, right? So 2E will be equals to 110. Then when you divide by 2 both sides, you can see that E is equals to 55. All right. This was the first way I could do this. I'm going to show you the second way I could have done this. No? Don't worry, you'll be like me one day if you keep on following me. Thank you very much. Okay, so let's erase everything. So the other way I could have done this is this, guys. I could have seen that the whole of angle H is 90 degrees. Why? Because angle H, which is that, is from is from J and this side is from K, you see? So angle H, we say it's subtended by J, and then that side is subtended by K. So it's subtended by JK, which is the diameter. The diameter always subtends a 90-degree angle. So I could say, okay, angles in a semicircle. If you haven't watched the video about this in this playlist, please do so, ladies and gentlemen. I think that is video number 2 in this playlist. Okay, no, it's video number 7. Go check video number 7, ladies and gentlemen, where I speak a lot about angles in a semicircle. Okay, so now I have 90. I have proven it. I have 35. I can easily get this angle using this big triangle, you see? So you can see that angle E will be the same as 180 minus 90 degrees, which is H, minus 35, which is K. And then your reason will be sum in a triangle. You can just say that if you want to. Or some angles in a triangle is also fine. And then you can see that E is still 55. But this was quicker. So it's very good to know all your theorems, ladies and gentlemen. Actually, it's compulsory. Let me not say not very good. It's very compulsory to know all your theorems, ladies and gentlemen. Let's now go to the next part of this video. Here, we need to get F, right? We need to get F. Remember, I said this, ladies and gents. I said, if you have a situation like this, you're always going to create a V then, just finish it up like that. Because it helps you to see it nicely. So I move from this point, I go there. I move from this point, I go there. Right? Sure. So this angle, this one, will go with that one. You see, they always go like this. This one goes with, sorry. This one goes with, so this one will go with that one. Eh? And then if I have another thing here, the bigger one here will go with that one. You see? So this one will go with that one on the center. You see? Angle at the circumference is 2 times angle at, angle at the center is 2 times angle at the circumference of a circle. Right. So now let's check, let's try this. You can see that, okay, this angle here, I'm going to call it O1. Angle O1 is the same as 360 degrees minus 120, which is a revolution, right? The reason is a revolution, or some people say angle around a point. Angle around a point. That is the other reason, same as revolution. You can use any of the two. And then here you get 240 degrees. So O1 is 240 degrees. All right? Which means O1 is 2 times F, right? Because angle at center equals to 2 times angle at circumference. And then you can see, okay, you substitute that here. O1 is 240. And then you divide both sides by 2. It gives you 120 degrees. It's angle F, which is the whole of H. It's also 120 degrees. And that's it about this video, ladies and gentlemen. Thank you very much. Aluta continua. Tangu.